Phytoplankton are small aquatic plants that are essential to both freshwater and marine ecosystems. But sometimes these phytoplankton can grow out of control in what are called harmful algal blooms. Some phytoplankton produce small, otherwise harmless amounts of toxins, but when they bloom, they can add a significant amount of these toxins to the water. This is bad news for the people and animals that depend on that water for drinking or recreation. Harmful algal blooms can happen in both fresh and saltwater. However, there is evidence that cyanobium, a type of phytoplankton, can make its way from freshwater into saltwater. This is troublesome because the two types are usually studied separately. Researchers test saltwater for phytoplankton that grow in saltwater and freshwater for those that grow in freshwater. However, this allows freshwater phytoplankton to exist undetected in saltwater systems. Now, imagine you had a machine that could detect unwanted raisins inside of your chocolate chip cookies. This machine works super well for protecting you from those disappointing raisin-filled bites of cookies, but it is bad at detecting another cookie-ruining additive, say cranberries. Similarly to freshwater cyanobium in saltwater, the cranberries would be lying undetected in your cookies. The goal of my project was to develop a process that would help us detect and distinguish the difference between freshwater cyanobium, the cranberries, and marine phytoplankton, the raisins. To accomplish this, we examined the DNA of cyanobium and determined how it was different from the DNA of the marine phytoplankton. Once we knew the genetic differences, we could make our machine detect both the freshwater cyanobium and the saltwater phytoplankton. This will help us keep the waters safe from potential harmful algal blooms and protect the people and animals that depend on clean, safe water.